We talked about some ways of looking at the graph of the quadratic and finding the zeros from the graph. Now we're going to talk about doing that with the calculator. So I'm going to use y equals, and I think it's really helpful for the kids to start making that connection with variables that even though I have a y here, I'm going to type an x into my calculator. So I have x squared plus 9x plus 14, and mathematically it does the same thing as if I put a y or an x there. And I'm going to hit graph. When I look at my graph, I can see that it has two roots visible to me. It looks like they're going through nice numbers, so I'm wondering what those numbers are. I'm going to use the calc key. It is blue, so I'm going to do second calc, and look at that. Zeros are there, which is what I'm looking for. So I'm going to press enter on zeros. I need to tell it where to look for them. And I don't see my
left or right key. Keep moving to the left.
Okay. Oh, there's my little thing. I'm going to start with the left. So I got my little flashy thing going around here, and I need my left bound, so I need to be past where I see the left root. I'm going to press enter, and then I'm going to go down past the 0, and I'm going to press enter. I do not ever guess. I'm just going to press enter, and it tells me that at x equals -7, that is one of my zeros. I'm going to do the same process with my right 0. So I've got my enter with the little thing. I'm going to go past it. I want you to notice that up here you can see little arrows that are the boundaries. It's got to be in between those, and I'm going to press enter, and it tells me that x equals -2. So I'm now going to solve these equations. So I have x equals -7, x equals -2. I'm going to add 7 to both sides. So I get x plus 7 equals 0. And over here, x plus 2 equals 0. Now looking at my graph, both of these are negative roots because they are on the left side of 0, 0. To show you that it's the same equation, because I could write this as x plus 7, this is the factored form, and x plus 2, I'm going to go back to y equals. In my y sub 2, I'm going to put the factored form in, and this is really important to help the students make the connections that they are the same things. And because I want them to see this is happening, I'm going to arrow all the way over to the front, and the one I like to use is the little 0 that has the tail, because it'll leave the tail behind it, but it will move. So when I hit graph, there's my first one, and then we see the little dot moving along, just show us that it's exactly the same thing.
Why don't you go to table and show how you can verify from the table too?
I can also go to my table, maybe, and I can see that at -7, 0, in both of them, I have my x equaling -7, and I have zeros for my y's, and the same with my -2. The other option I can also do, which is very interesting for the kids, I'm going to clear this one out, is I can put in the linear format of this. So I'm going to put it into my y squared and into my y2 and my y3. And what this will do is show you that those linear equations cross at the zeros. That each of those factors is actually equal to 0. Now, you may not want to do that day one with all your kids, but it is an interesting thing to see that when we talk about this equaling 0, that is where those systems intersect.
So that would definitely be an extension piece.
It would be an extension piece, but it's very, for those kids that have a concept of, or even those that are somewhat confused sometimes with the zeros, that shows that it actually is the 0 of the equation. We're going to look at this one as a squared plus 12a plus 36, and again I'm going to use the calculator to help me find my zeros. And I'm going to put in x squared plus 12x plus 36, and I just want to point out 36 is another one of those numbers that has a whole lot of factoring. So having kids guess and check with 36 can be a difficult task. They don't see all of them. But I'm going to look at this graph. I noticed something about this graph. It appears to not have, it appears to be sitting on the x-axis, so I'm going to see what the zeros happen to be. So when I go to second calc to get my zeros, again it wants my left bounds. I got to find my little cursor thing there. Where is it?
Keep going. Keep going to the left.
Keep going to the left, Kathy tells me.
Whenever you turn it on, it starts at 0, 0.
Oh, good to know. Well, I just thought it was magic. So I'm going past it, I'm pressing enter, and I'm going to go past it again, and I'm pressing enter, and it tells me that my 0 is at negative 5,99999. Let me look at my table. That tells me my 0 is at negative 6. And it also tells me that it's the only 0 that I have. So I have x equals negative 6. Because it's quadratic, I know I need two factors. Well, x plus 6 equals 0, and I know I need two factors. So it means I have x plus 6, or x plus 6 squared. And when I'm going back to my graph and I see that with my 0, it may be the format of how I have things, and the table setting, no, my mode of how I may have things, and the rounding issue that will happen with the calculator. It's that rounding issue that keeps you from wanting to use the trace key to find this. You actually want it to calculate. And I went to the table to verify because I knew that negative 5.669999999 was really close to negative 6, which is a factor of 36. So I'm going to go back to my y equals. I'm going to put in for my y2 so that I can see that it's the same. I'm actually going to put in as x.6 squared. And this time I will go make the line a little thicker. Whoops, I went past that. So that they can see that it draws right on top of the old line. So I have my original graph and the new graph on top. I'm going to factor one, or use the graphing calculator to help me with the graph that has a leading coefficient other than 1. And I think it's really important to talk about with the kids that there is a coefficient to x squared, we just don't write it. So we need to use that terminology of coefficients other than 1 because 1 is there already. So I'm going to do y equals 3x squared plus 11x plus 6. I'm going to look at my graph. Okay. It looks to me like I have one that is crossing at a rational and one that is in between. So I would be asking the kids at this point in time, where is that fractional number happening? It is somewhere between 0 and negative 1, so that when they start looking for answers, we have a possible choice that makes some sense, and you can talk about reasonableness. So I'm going to see if I can calculate my zeros. And I've learned now it starts at 0, so you have to always go left with my little funny thing. I'm going to press enter, and then I'm going to go past the 0 and press enter again. And I get one of my zeros is x is negative 3. And when I go to calculate the other 0, I am on one side of it, and I press enter. I'm on the left side of it actually. I go past it to the right side of it, and I press enter, and it tells me my 0 is negative 0.66667, which means I know it's negative 2/3. That should be a decimal representation that the students should know as one of our benchmark decimals. If I go to the table, I will notice that at negative 3 I'm at 0, and between 0 and negative 1 something happens because I go from a negative 2 to a positive 6. I'm not going to see it on the table because it's a fractional representation. So to get my factors, I have x is negative 3, x is negative 2/3. So this tells me x plus 3 by adding 3 to both sides is 0. I'm going to multiply to get that denominator changed. So I get 3x is negative 2, which when I bring my 2 over, I add my 2, and my factors are x plus 3, 3x plus 2. And I might be talking to the students at this point in time is that we would know that the 3 needed to be in one of our factors so that I could get, because the only way to get 3x squared is a 3x times an x. And I'm going to put my factors in from their factored form. And again, I like the little one that's either just the floaty little dot or the one that is the tail or the no tail, because I see the movement of it, and I think that's really important for the students to see it move through it. Okay, I'm still working with this problem, 3x squared plus 11x plus 6, and I'm going to my graph. I'm calculating the fractional piece, finding that 0 that is between -1 and 0. I'm going to go to the left and to the right, and I get this. At this point in time, that value is stored in X. So, if I go to my home screen, so I do second mode and I go to home, if I press my X and then the math and enter for fraction and enter for it to calculate, it will give me my -2/3. So if your students do not know those benchmark decimal fraction relationships, it is stored in X, and you can use the math enter key at the home screen to make it a fraction.
And it will only change it if it's a rational fraction. If it's
Right.
irrational.
If it's irrational, it won't change. Okay, this is one of those quadratics that the students believe should factor, because 2 and 3 have a relationship to 5, and 2 and 3 have a relationship with one's positive and one's negative to X. The problem is 2 times 3 is not 5, it's 2 plus 3 that's 5. But they see it as something that can be factorable. So, we're going to talk about that. We're going to do my y equals, and I'm going to do x squared plus x minus 5, and I get my graph. It looks like it should have some very nice zeros. So let me calculate them. And I'm using the left and right arrow up here to get to them. And that's not a real nice zero after all. It's -2.79, yada, 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 yada. So I'm going to go to my home screen and try the trick I used a minute ago, because that's stored in X. And I'm going to do X, math, enter, enter, and it gave me back that nasty number. It gave me back the nasty number because it's an irrational fraction. It's not something that can be written as something over something where those two somethings are integers. So let me see if I can do better with the other 0. So second trace, 0. And I'm going to come over, and I'm on this side, and I'm going to the other side of that number. And I get a similarly looking number, so maybe I'll have more luck with this one. I'm going to do X, math, enter, enter, and it also gives me back, because these are both irrational, I know this cannot be factored. Or you may say that it's prime, not factorable.
I like this point because this is such a key concept that they really build on in Algebra 2 about whether they're rational or irrational roots. And it really starts that conversation here with factoring.
Well, and the other thing that it brings up is there are solutions. There are zeros to this. I see the zeros there. There are 2 zeros. The problem is the zeros are not going to be able to come from factors, and this leads directly into why you even need to talk about the quadratic formula, because I need to find those answers. This is just the way I'm going to have to find them.
Right.
To the problem that we did a moment ago where similar to the problem we did a moment ago that was prime, this one to the students frequently looks like it can be factored. Again, it has to do with the concept of 6 being a 2 and a 3. We know 2 times 3 is 6, and 2 plus 3, when one is a negative, can be 1. But there's no negatives in the problems, and that can throw the students off. So one of the options of using a calculator that it gives you is the freedom is to be able to do these problems and help the students to see that not everything is not only factorable, but not everything has real or rational roots or zeros. So when I do x squared plus 6 and I graph it, I can see it is not crossing the x-axis. It's floating above it. So there's no x-intercepts and there are no zeros because it's not crossing where x equals 0. So I don't need to spend a lot of time factoring it. I actually don't need to spend a lot of time in Algebra 1 with the quadratic formula, because in Algebra 2 what we will learn is that it has imaginary solutions.